Hello friends, myself Professor Prashant Mahajan. I'm working as an assistant professor at AISSMS Institute of Information Technology. So in the last lecture we have started instrumental methods of analysis, and in that lecture we have seen electrochemistry, its definition. Then we have seen types of cell, the electrode potential, oxidation potential, reduction potential, and in the last we have seen Nernst equation. So today we are going to see next part, that is reference electrode. So first, that is definition of reference electrode. It is defined as the electrode which has stable and reproducible potential and completes the cell, acting as half cell. So means what? This reference electrode will combine with the indicator electrode and it will complete as a cell. So it will be acting as half cell. So what is the purpose of reference electrode? First, to complete the cell, and second, it provides the stable potential. So these are the some types of reference electrode: standard hydrogen electrode, standard Calomel electrode, indicator electrode, and ion selective electrode. So first, it is Calomel electrode. So it is reference electrode. So you can see the diagram at the bottom. There is a mercury. Then there is a mixture of mercury and mercurous chloride. Then that platinum wire is dipped in that solution. Then saturated case oil solution is there, and there is a gel that will act as a salt bridge. So this calomel, it is nothing but the alloy of mercury. Sorry, it is the ore of mercury, that is Hg2Cl2. So this is the diagram of that calomel electrode. So this is the table which shows you the different values of E0 calomel when different concentration of the KCl solutions are filled. That means when we fill this Calomel electrode with saturated KCl solution, then the value of E0 will be 0.2422 volts and its name is saturated Calomel electrode. When we replace this saturated solution by one normal solution, that value will going to increase, that is 0.2810, and the name of the electrode is normal Calomel electrode. Then in case of 0.1 normal, it will become 0.3334 and the name will become Desi normal Calomel electrode. Next is construction of Calomel electrode, that platinum, then mercury, then mercurous chloride, and then KCl. Generally, we are going to use saturated KCl solution. So you can see from this table, as concentration of the KCl solution increases, the E0 value of that calomel electrode decreases. So if calomel electrode acting as a cathode, so this is the reaction: Hg2Cl2 plus twice electrons, it will give you twice Hg plus twice Cl minus. So as in the case of oxidation, the Nernst equation is E cell is equal to E0 minus 0.0591 upon N log of product side upon reactant side. So product side is Cl minus and reactant side is Hg2Cl2 and number of electrons is 1. So that is divided. So that will be the your first equation. If calomel act as an anode, that will be the second reaction. So these reaction and these reactions both are equal and opposite, and this formula will become E cell is equal to E0 cell minus 0.0591 log of 1 upon Cl minus. So there are some demerits of calomel electrode. First, we cannot use calomel electrode above 70 degrees Celsius as Hg2Cl2 start decomposing. And second, it involves handling of poisonous Hg and Hg2Cl2. So that are the disadvantages of or demerits of Calomel electrode. Then next is indicator electrode. So in the case of indicator electrode, we are going to see. So indicator electrode is the electrode of the cell in which the potential depends on a particular ion concentration, that is called as indicator electrode. For example, glass electrodes. So the concentration, uh, the potential of the glass electrode, it is depend on the H plus ion concentration. So you can see the principle, that is when two solutions of different H plus ions are separated by a thin glass membrane, a potential difference is developed as proportional to the difference in the H plus ion of the two solution. That means you can see in the diagram there is 0.1 molar HCl solution is there, and we are going to dip that glass electrode containing acid solution. That means in that we are having HCl solution inside the glass electrode or glass membrane, and when we are going to dip it in the beaker, there is another solution which is having another concentration of HCl. So if there are two different concentration of H plus, then there will be a potential difference, and that is measured by this platinum wire. So you can see the diagram, glass bulb is there, that is thin walled glass bulb. Electrolyte is 0.1 molar HCl, then glass tube is there, then platinum wire is there. So the reaction taking place at the glass bulb is there is an exchange of sodium and H plus. So H plus from the solution get exchanged with the Na plus from the glass bulb, and you will get Na plus plus HgL minus. So the reaction or the formula will become Eg is equal to A0G plus 0.0591 pH, and the representation of the cell is Ag, comma AgCl, then 0.1 normal HCl, H plus, and then glass membrane. Next is, while using the glass electrode, we have to soak that glass electrode in water for 1 hour before use. The reason behind it is the surface of that glass electrode should become active. So for that we have to dip that glass electrode in water before use for at least 1 hour. So the reason is, first surface become active, then hydrated layer developed on the outer glass surface, and ion exchange will become easy. So there are some advantages of glass electrode. First, it is stable electrode and can be used in the presence of strong oxidizing and strong reducing agent. Second, it is compact and portable. So you can see it is compact and portable in the diagram. So this is there. Next is it attains equilibrium quickly. Fourth one, it can detect and estimate H plus ion in the presence of other ions. And fifth one, it is simple to use. So that is glass electrode. Next is determination of pH of the solution. So for the determination of pH of solution, we require two electrode. One is indicator electrode and other is glass electrode. So you can see in the diagram. So this is indicator electrode which we have seen, sorry, this is Calomel electrode which is acting as reference electrode, so which we have seen earlier, and this is glass electrode which is acting as indicator electrode. Means we know the standard electrode potential of this calomel electrode. If we are using saturated calomel electrode, saturated KCl solution, then that value is 0.2422. So this is the combination of glass electrode and calomel electrode. So that will become calomel electrode, then salt bridge, then H plus of unknown concentration and glass electrode. So the E cell value will be E calomel minus E glass. That will be E calomel value we know from the table, that is 0.2422, and Eg value, that is from the last slide, that is this one, that is E0Z plus 0.0591 pH. So by putting this value you will get this. So after that we want pH, so this will go to the other side. Okay, so this will be minus, this will be minus, so this side will go to this side, that will become plus, thus E cell will come to this side, so that will become 0.2422 minus E0Z minus E cell, and then this side 0.0591 come to the other side, so here it is multiplied, here side, this side it will go to the denominator side. So that is the determination of pH of the solution by coupling glass electrode with calomel electrode. So that is the reference electrode, that is calomel electrode, and indicator electrode as a glass electrode. Thank you.